So here we go with a lesson on solving systems of equations graphically. And by the end of this, you should be able to not only solve it, but also be able to tell me how many solutions there are based on the graph. So let's get right into it today with graphing these two linear equations. We're still working with just straight lines. Now the first one is already solved for y. And when we see that, we like that because it is in slope-intercept form. So I know the m and I know the b just by looking at the equation. The m is always in front of x, and when there's not a number there, we can say that it's 1. And whenever we have a number like 1, we can put it over 1 to give us a rise and a run, and the y-intercept would be 3. Now with the next equation, not so nice, because this one, not solved for y, has 2x on the same side of the equal sign as y. So it's our job to solve it for y. If you haven't been able to make it the last few classes, here's what we've been doing. We've been trying to get y by itself by using equation rules. So if it's adding 2x, you subtract it. And when you are trying to add or subtract unlike terms, don't do it because it can't be done. Simply write negative 2x minus 3. Keep the sign in front and rewrite this in slope-intercept form. So now that we've done that and gotten y by itself, we've got m at negative 2 and b at negative 3. And don't forget, we can always put that slope over 1 when it's just a regular old number so that we have a rise and a run. Now it's up to us to graph this on the coordinate plane. So we're going to start where we always start, and that is at the y-intercept. So I'm going to go back to my blue and going to go up 3, 1, 2, 3 on the y-axis. Saw on a few Jamboards that we're still using the x-axis. Remember, y-intercept, y-axis, it's the one that goes up and down. Now we're going to rise 1, run 1, up 1, over 1, up 1, over 1, up 1, over 1. We could also go down and down and left, down and left. As soon as you have enough points to see that this is a nice straight line, go ahead and extend it, put arrows on it, and don't forget to label it, especially now that I have more than one line per graph. Okay? So there it is labeled. And that's, again, a review of what we already done. What's new today is putting a second line on the graph. And there's plenty of room for more. So let's go down 3 and start at negative 3 on the y-axis. Now this is a negative slope, so it's going to go down 2, right 1, down 2, and right 1. Now you can see that I'm going away from the line that I just graphed, the blue one. I want to try to go towards that line, and I need to find exactly where these meet. So I'm going to go up 2 and then left 1, up 2 and left 1, and haha, I have found where they meet, and that's going to be important to us. Now we did this with the graphing calculator. We're doing this with our paper and pencil today to show you that where these two lines meet is the solution to the system of equations. So this is y plus 2x equals negative 3. But more importantly, we have found this point right here. This is the solution to the system, and it happens to be at 2 to the left, up 1, for negative 2 and 1. So there you have it. Where the two lines meet is the solution. Now, how many times did they meet? Just once. So we consider this a one solution system of equations. All right, so there you have it. When the lines meet once, you have one solution, but that's not always going to happen. So let me give you a couple other examples here. This one has two equations, and one of them is already solved for y, so we're all excited about that. So we want to know what the slope and what the y-intercept is. Well, the slope of this is good old 3, and the y-intercept is negative 2. As for the bottom one, of course, they've given us a little bit of work to do because y is not by itself. So first things first, always want to try to subtract 6x on both sides. We could divide by negative 2, but just we have a process that we've been following, so let's keep doing it. This zeroes out, okay? takes it away from this side, puts it over on this side as negative 6x plus 4. Do not add or subtract unlike terms. You can't do it. Now, let's go ahead and do the last step, which is to divide by negative 2. Always undoing the operation that's being posed. So if it's multiplying by negative 2, I divide by negative 2. So this ends up with y. Simplify when we can. A negative 6 divided by a negative 2. How about 3 followed by the x? And then 4 divided by negative 2 is going to be negative 2. So we've got our slope. We've got our 3 over 1. And we've got our y-intercept. So now it's up to us to graph this to see what it looks like. Now, this is kind of weird. The slope of this and the y-intercept of this is the same as this. Well, let's just kind of see what happens. So negative 2 is the y-intercept, and then it's going to rise 3, 1, 2, 3, over 1. Positive slope goes up as it goes to the right, maybe a couple of points down low. I'm going to go ahead and connect these points, put an arrow on it, and label it with the original equation 6x minus 2y equaling 4. So I've graphed that one. Time to graph the blue one. Well, what's going to happen here? Negative 2 on the y-axis is the same point I started at last time. A rise of 3 and a run of 1 is the same slope. So what we have here is actually the same line. These two lines are identical. They have the same slope and the same y-intercept. Now don't be confused by the fact that their equations were different when we started. When we solved them for y, they ended up being the exact same. So this is a situation in which the lines have an infinite number of solutions. And by infinite, I mean they have the exact same solutions. Because they're a slope, because their y-intercept was the same, we're basically dealing with the same equation. All right, we are dealing with the same equation, right? So far we've had one solution, then we did infinite solutions. Let's see what the third one brings us. Now, the third one has an equation which is y equals 3x minus 5. And consider the slope and the y-intercept for the first one because it's already been solved for y. M is 3 and b is negative 5. Thank you to those that answered the poll question correctly. Down here, we're going to have to solve for y. We can't tell the slope and y-intercept until we get y by itself. So if it's subtracting 6x, let's add the 6 and the x to both sides. That clears it out. It's no longer on this side. It does reappear over here as 6x plus 4. Final time I'm going to say it. Don't add or subtract unlike terms. Put the slope before you put the y-intercept. Keep the sign in front, 6x plus 4. Divide by 2, divide by 2, divide by 2. This is going to give us the one that we want. It's still going to be equal to, simplify when you can, 3x plus 2. And again, here's your slope, here's your y-intercept. Now, something curious, if we're just looking at this, I've got the same slope. Oh boy, I wanted to use red for this, so I'm just going to go back here. This is my red one. I've got the same slope here that I do up here with the 3 over 1. So that's going to be interesting. Let's go ahead and take a look at what this looks like on the graph. First one in blue, let's go down 5, 1, 2, 3, 4, 5. Put our first point on the y-axis because it's the y-intercept. And then we're going to rise 1, 2, 3 over 1. 1, 2, 3 and 1. 1, 2, 3 and 1. We've got a line. It's a linear equation. Go ahead, extend the line, put arrows on it, seal the deal with its equation. There you have it. We have graphed the top or the first equation. Now the other one that I wanted to do in red to make us kind of see the difference between these two is 3x positive 2 for the y-intercept. So we've got positive 2, which is up 2, but then it's going to rise and run at the same rate. 3 and 1, 3 and 1, 3 and 1, and 3 and 1. So we would go ahead, connect these points, and see that this line is never going to intersect the blue line. So I label them both so I can tell them apart. and we've got another situation on our hands. In this case, because they never intersect, there are no solutions. There can't possibly be any solutions, right? Because we're looking for where they meet, and since they never meet, they have no answers.